the adaptive immune system, or the specific immune system, is divided into two main responses. One is known as the cell mediated response, covered in a different video, and the second is known as the humoral response. That is the subject of today's video. So let's get started. The immune system can be a fun and incredible body system capable of helping keep us protected from foreign invaders. Awesome. So, anytime that we're thinking about antibody production, we should be thinking about B cells and their contribution to the production of antibodies. B cells are a unique type of lymphocyte, and this lymphocyte is able to present antigens on its surface. Now, in another video, we're going to consider how B cells can be coordinated and activated by helper T cells, but in this situation, in the independent humoral response, we're going to look at a very elemental discussion about how B cells are able to autocrine signal or self-signal when it is time and appropriate to create antibodies, as well as creating memory cells. So we're going to think about our B cells today in the function where they work to present an antigen and then self-signal to respond to a perceived threat. Okay, for this discussion, we are going to remind ourselves that B cells are a type of lymphocyte, so a subgroup of lymphocytes, and they are named B cells because they are born of the bone marrow, as are all blood cells, but they're also B cells are also going to get their education about self versus not self in the bone marrow. And I like to joke that this is called bone marrow community college. Now, B cell, we're going to illustrate these in this kind of yellowish color, is going to be able to bring in foreign particles. This is going to process some antigen. So much like other cells, they're able to bring in these little foreign substances. They are able to determine whether or not those foreign substances are dangerous or not dangerous. And if that foreign substance is determined to be dangerous, they can, like other antigen-presenting cells, put an element of that antigen from that pathogen on the surface of the cell. Once an antigen is on the surface of the cell, this B cell, put a big B in the middle to remind us where it came from and where it went to school. This B cell is ideally going to do something with this pathogen. Now, B cells are able to do a process we call autocrine signaling. An autocrine signal, I'm going to write this over here as a reminder, an autocrine signal is when a cell or cells are able to self-signal. So this is what I like to joke is the existential crisis of a B cell. Oh gosh, I ate this little red thing. This red thing I think is dangerous, and I'm going to put it on the surface of my cell. Is it really dangerous? I think it's dangerous. I feel like it's dangerous. What should I do with this thing? So a B cell is going to be able to self-stimuli, self-communicate. And just like other cells, those cell communications are going to be in the form of a broad category of chemicals called interleukins, Leukins, interleukins. And these are cell signals. Now, under normal circumstances, we might have different immune system cells sending a signal out, helping educate or tell B cells what to do. But cells that are able to autocrine signal are able to release interleukins to themselves. They're able to self-signal. Interleukins come in a wide variety of classes. They are going to be specific to the type of cell that they are communicating with. And in our case, for the A&P level that I am teaching, we're just going to call them interleukins, and we're not going to necessarily talk about the specific languages. I like to joke about interleukins being different languages like B-cellese or macrophagese or T-cellese. So languages, these interleukins are languages that these cells are using to communicate with each other. So remember, my B cell over here has found a little pathogen, has digested it, put it on the surface of the cell, and now it's in this existential crisis of, is this dangerous or is this not dangerous? Do I do something with this or do I not do something with this? And there's a little autocrine signaling that's going to happen through the interleukins. And so what happens is that the B cell, and I kind of draw these as if they're looping back to each other, are going to release these little chemicals, these little interleukins. And that interleukin is a method by which the cell can self-signal to autocrine signal itself that this is truly a pathogen. This is truly something that doesn't belong, and we want the B cell then to feel empowered to elicit effects, to make changes to help keep the body safe. So, once a B cell has self-signaled with its interleukins and it has convinced itself that there is indeed a threat, that threat is dangerous and it needs to act, the B cell is going to go through some similar steps to what we see in the cell-mediated response. All right, let's add some steps. Very first thing that this B cell did was to bring in and ingest this foreign substance. It did its antigen presenting thing, and it presented the antigen too on the surface of the cell. Now, while B cells can communicate with other cells, they also can self-communicate. So the third thing that happened was the release of these interleukins, and the green arrow is to remind ourselves that this was an autocrine signaling. Once the B cell has convinced itself of a foreign invader and it needs to react, it's going to start to go through a differentiation process. So I'm going to draw a little arrow over here. This B cell has now been educated about a foreign threat, and now it's time to respond. So the B cell, later in time, so this arrow might represent time, and a little bit further down the line, this B cell is going to start to do a process called clonal selection. So that is essentially mitosis. And what was one B cell or two B cells, a few B cells that learned about these foreign invaders, now we're going to start to create what I jokingly refer to in a Star Wars reference, the clone army. This step is called clonal selection. And during clonal selection, we're going to create a whole bunch of new B cells. This is going to take a little bit of time. This is why your first exposure always takes, on average, 7 to 14 days, because it takes a little time to get all of these things rolling. Now, in that time, these B cells that are clonally selecting are not just clonally selecting, but they are now jaded. They have been educated, and they have determined that this molecule, this antigen that they brought in, is dangerous and needs to be dealt with. So over here, we have what is frequently referred to as a naive B cell. But when a B cell eats a little molecule, presents it on its surface, does a little autocrine signaling to self-stimulate, and determines that it's dangerous, that's when clonal selection is going to hit. And when clonal selection hits, the next step then is to start to utilize these cells for two different effects. So, effect one. Effect one, for most of these cells, okay, so here's a little more time. Maybe I should write my little time in a different color. And these cells are going to begin to change shape. They're going to elongate. They're going to start to master the processes of transcription and translation. And we're going to call these cells, at this point, plasma cells. And these B cells, these are a B cell. These came from the clonal selected army. These B cells are going to start increasing the rate of transcription and translation. We'll put T and T for transcription and translation. And they're going to start to crank out antibodies. Now, antibodies are a Y-shaped structure. And that Y-shaped structure is the constant region of the antibody, but these antibodies are then made specifically for the thing that the B cell wants to attack. So in this case, because we have a ball, we're going to put a little variable end to it that's round so that it could hook to the ball shape of the thing that the B cell decided was dangerous. So the vast majority of B cells are going to create plasma cells and start cranking out antibodies. And in about 10 to 14 days after the first exposure, is when we're going to start to see large amounts of antibodies in circulation. However, when this clonal army is being created, a group of the B cells, a few of the B cells, are going to come over and they're going to create what I think of as the National Guard, a reserve army. So we're going to get a couple of B cells over here that are going to become memory B cells. And those memory B cells already know about this ball that was determined as the foreign dangerous invader. So this set of cells, these memory B cells, are really critical. And what these memory B cells do is they hang out for the next infection. These guys are really crucial in our second or third or fourth infection. And in a second, third plus infection, these memory cells really quickly can turn into a plasma cell. And that allows for a much more rapid response in the production of antibodies. So let's consider this one more time in summary. Initially, a naive B cell is going to process an antigen, and if it determines that that antigen is dangerous, so we have step 1 here, if this is dangerous and is presented, it'll go through step 3 over here with my interleukins and autocrine signaling. This is going to tell the B cell, yep, I really am convinced that something dangerous is here. What that then leads to is, over time, step 4, we'll put a 4 up here now by clonal selection, because now these cells are going to go through mitosis and they're going to create a whole cohort of B cells that are familiar with the ball antigen that the original B cell determined was dangerous. As a reminder, this is mitosis, and mitosis is going to take a bit of time. So to create our clone army, we have to have a little extra time. Once the clone army has been created, then these cells are going to differentiate a little further. Some of them, most of them, are going to go to this upper arrow, and they are going to become a plasma cell. The fifth thing that happens is the plasma cell is created, it's going to change its shape, and then 6, it's going to increase its rate of transcription and translation and start to crank out 7 massive numbers of antibodies. Okay, now remember, first exposure, this takes 10 to 14 days, but over here, we're going to write a second exposure, and in a second exposure, with previous knowledge, the antibody increase can happen in as little as 24 to 48 hours. So a much more rapid response if we have memory cells. Now, where do the memory cells come from? Remember, during the time that some of these cells were generating and creating the plasma cells, a few of the cells are getting recruited to a reserve army. And those recruited cells are going to not form antibodies immediately, but rather go on reserve. And as they go on reserve, we call those the memory B cells. So while 5 is happening and we're turning into plasma cells, at the same time, we're starting to crank out some memory B cells. And those memory B cells are then able to already know about the antigen. So when it comes to the second or the third infection, the cool thing about this is that then this memory B cell can use that interleukin signaling again and can very rapidly indicate to itself that autocrine signaling indeed needs to react. And as it reacts faster, you can see our line over here from second infection. This can very quickly then convert itself into plasma cells, start the transcription and translation process, start cranking out antibodies all over again. Time for our key ideas. So, B cells come from and are raised in the bone marrow. So the bone marrow is where they're going to learn about, I'm going to put my joke of community college up here. B cells are going to figure out self from not self, dangerous from not dangerous in the bone marrow. The progression of these cells can happen all on their own without any other signaling. So B cells are capable of responding to autocrine signaling. And when autocrine signaling happens, this begins the cascade. What is the cascade that we see? The cascade with the B cells is that we start with a B cell. The B cell is naive. The B cell then learns about a foreign molecule, okay, determines something that's dangerous. So now the B cell is aware of a dangerous thing. And that dangerous thing then is going to cause some autocrine signaling. Now, as the autocrine signaling is happening through interleukins, okay, via interleukins, this is going to then cause clonal selection. That's fancy talk for a rapid rate of mitosis to create a whole bunch more B cells. Those B cells then are going to differentiate, many of them becoming plasma cells, and the plasma cells are the cell that makes the antibodies. Little proteins floating in the plasma of the blood, thus the name plasma cells. The other effect is to make some memory B cells, and the benefit to memory B cells is that we're going to be able to mount a quicker response if we're ever affected with this dangerous antigen again. Now, B cells produce a number of types of antibodies. B cells can last for a number of decades. It's a really cool feature of this cell type. So if we can get B cells educated, then they can help protect the human body for an extended time frame. And from a clinical standpoint, the way that we try to educate B cells is through the use of vaccines and through the use of antigen therapies, as opposed to getting sick with the disease, which is never much fun. Hope this helps you understand how a B cell can self-signal itself and helps you understand the independent B cell response. However, recall that B cells also can be signaled by other cell types, and there is a video called the Cell Mediated Response to help you understand how a B cell might be more effective and quicker in response when it is signaled by other immune system cells. Have a great day.